Today we're starting Chapter 11. Chapter 11 is on right triangle trigonometry. So what shape are we going to be working with? What kind of triangles? Right triangles, which means they all have right angles in them. Alright, the first lesson we're going to talk about some similar polygons today. So let's first get to what similarity means. Alright, do I have a volunteer? Alright, Brittany, come on up. We're going to measure the corresponding angles. So let's measure angle A. Brittany, what does that look like the angle measure of that angle is?
90.
90 degrees, thank you. So this is 90 degrees. Now what does the measure of angle X look like? 90 degrees, okay. You want to try it now?
Sure.
Alright, take this and move it so that the bullseye right there is on the corner. Okay, go ahead and measure angle C. You have to touch and just hold. You can hold it anywhere in there. You don't have to hold it on the bullseye, yeah. Good. Yeah. What does that look like to you? How many degrees?
30-ish.
30-ish. How about 32?
Yeah.
Okay, so Brittany says that's 32 degrees. What angle corresponds to angle C in the smaller triangle? Z. Okay, go ahead and measure angle Z. There. Don't pick your finger up. Got to hold it the whole time.
Okay. There.
What does that look like there? 32 degrees. So do we need to figure out and measure the third angle in each one? No, because we know what? There's 180 degrees in each triangle. Very good. Thank you. There's 180 degrees in each triangle. And since we know two of the angles, we can subtract to find the third, right? We take these two and add them up to get 122. And then subtract that from 180. 180 minus 122 gives me what? 58 degrees. So we know this is 58 degrees. And we know that angle Y is 58 degrees. So what can we say about all the corresponding angles? They're all what? They're all congruent to one another. Very good. Yes, they are congruent. So, since the angles are congruent, are the triangles congruent? Those two triangles are exactly the same. Congruent means everything's exactly the same, the size is the same. Like, no, they're still different, right? And we can get that just by, what do you notice? Well, I notice that all corresponding angles are congruent. I notice that, but when I grab this triangle XYZ and slide it over here to ABC, I notice what about the sides? They're not the same. The side lengths are not congruent. So we have a little problem here. Alright, well, let's take a look and find the ratio of the lengths of the sides, which means I'm going to take the side from one of the triangles and put it over the length of the side from the other triangle. This is a metric ruler I'm going to use, so measurement will be in millimeters. Alright, for this side right here, the side AB, AB is about 57 millimeters. So AB is 57 millimeters. And this corresponding side, so whenever I go to measure these and I'm looking at it, I have to make sure I have the sides that are in the same place relative to each other in the triangles. Well, in this one, AB connects to this right angle and goes vertically, and that's the same as YX on this one. And when I measure YX, I get about 31 millimeters. So now I can compare those two side lengths and make it a ratio. I'm going to say that AB corresponds to YZ, YX, and the ratio is 57 to 31, which I could divide to turn into a decimal if I want to, and I divide 57 by 31 and I get 1.84. Okay. Let's check AC and its corresponding side XZ. Let's see what we get. So I'm going to measure those. And when I measure AC, I get approximately, come on, 85 millimeters. Right there. And then when we measure XZ, 48 or 49. We'll go with 48 for now. So now let's check that ratio. So we're going to look at sides AC corresponding to side XZ, and we get 85 over 48. 85 divided by 48 equals 1.77. So I'm going to change this and make it 47 millimeters. 85 to 47, and I get 1.81. So they're almost the same, right? You see that these two ratios are almost the same, 1.84, 1.81. If I wanted to be really, I could do 1.8 and 1.8. Then what would I say about those ratios of the sides? They're what? They're the same, right? The ratios of the sides are the same. And I'm going to actually make a point here in a minute. How are the triangles the same? Well, their angles are congruent, right? How are they different? The lengths of the sides are different, correct? But what do we notice about the ratio of the length of the sides? They are the same. And this leads us to similar figures. Those two triangles that I just had up there, while they're not congruent, they are similar because the angles are all congruent and the lengths of their sides are all in the same ratio. They all have the same ratio. And similar figures have the same shape but not necessarily the same size. That's why they're not congruent. The symbol, and this is called a tilde mark, is used to denote similarity. Remember with congruence, we had that tilde mark over the equal sign. Well, you take away the equal sign, which means they don't have the same measure or length, and then you're just left with similarity. So the figures will look the same, but they'll be what? Different size. So when I look at these two triangles, I have that the similarity is triangle ABC is similar to triangle DEF. Because I know that, or because I am given that, I can say the corresponding angles are congruent. Now, in order to have triangle similarity, you have to have one of two things. Either you have to be given that their corresponding angles are congruent, or their corresponding sides, which we'll list here in a minute, will have the same ratio. If you have one or the other, you can say they are similar. You don't need both. All right, now we're going to list the corresponding sides. And this is important. You have to make sure you match them up. So when you're matching up the ratio, when you have the lengths, that you have the right ones. So in this triangle, if we look at side AB, what side does it correspond to in DE? So yes, AB corresponds to DE. We did triangle congruence. This is similarity. It's a little bit different. Okay, AC corresponds to what? Side in DF. AC corresponds to DF. And then finally, of course, the last two, BC, would have to correspond to EF then. And if they were truly similar triangles, I could set up all three of these as fractions. And when I reduce that fraction or divide it and turn it into a decimal, I should get the same number each time. So we have definitely, if we have the corresponding angles being congruent, we have that the triangles are similar. That's one of the ways to determine triangle similarity. I'm going to fail that row in fourth period. It jinxed me. I hadn't had that problem all year until she said something last week, and now it's twice. The other way to determine similarity is to take and set up the lengths of the sides, the corresponding sides, as a ratio, and then see if I get the same ratio for all three sets of sides. So in this triangle, AB corresponds to what side in DEF? DE. So AB corresponds to DE. And what is the ratio of their sides? 4 over 10. Now, it's 4 over 10. Could I put 10 over 4? Could I do the bigger triangle first? Yes, as long as I do it the same for each set of two sides. If I do the smaller one on top here, I have to do it that way all the way across. I could do 10 over 4, and we'll see that for each one. All right. AC corresponds to what side in the other one? DF. 10 over 25, or if I want to do the larger one, 25 over 10. And finally, BC has to correspond to EF, and that would be 8 over 20 or 20 over 8, depending on which one you use first. So what I want to do now is you have two choices. You can reduce the fraction or divide and turn them into decimal. It doesn't matter. Because in all three cases, this is 2/5 or 0.4. This is 2/5 or 0.4. This is 2/5 or 0.4. And then if I did these on the bottom, they all equal 2.5. So in either way, do I get the same numbers? Heck yes. I get 0.4, 0.4, 0.4, or 2/5, 2/5, 2/5. So are they similar? Yes. So triangle ABC is similar to triangle DEF. So how many ways are there to determine similarity? It has to be division. No, it has to be a ratio. You can. Good question. How many ways are there to determine similarity? 2. That's right. 2 ways to determine triangle similarity, or polygon similarity. First way was angle congruence. All the 8 corresponding angles are congruent. The second way was corresponding side ratios are equal. Those are my 2 ways. Yeah, it's not a lot of heavy-duty computation or anything. It will get that way when we get to Pythagorean theorem and the special right triangles, 45, 45, 90, and 30, 60, 90, a little more. But you just have to, it's not terrible. And seniors, this is your last chapter. I'll give you the schedule for the rest of the year here after the lesson. Okay, well, even though we had said previously that this was basically having to pertain with triangles, we can also apply them to any polygons. Why? Well, does anybody remember the formula for the sum of the interior angles of a polygon? Well, with any polygon, if I go like this and draw some diagonals, what do I end up inside there. What shapes? Triangles. So whenever we find the total number of degrees in any shape, what we do is we turn them into triangles. And we use this formula. N minus 2 times 180, because we know there's 180 degrees in every triangle. So if we take the number of sides and subtract 2, that'll tell us how many triangles are inside each polygon. We did that in chapter 5, I think. So both of these are pentagons. And since we're working with triangles, we can use some of those properties of similarity. So since it's a pentagon, it has 5 sides. I can find that each pentagon, no matter what, has 540 degrees inside of it. Which means what? I could figure out either the total number of degrees are the same, the corresponding angles are congruent, and that would tell me these two pentagons are similar, or I could find the ratio of their sides to make sure they're all the same, and that would tell me they are similar. Well, I know this is 90 and this is 90 and so are these, and I have 150 and 60. I need to know the measure of angle C here and the measure of angle D prime right there. Okay, how do you know? How do you know it's congruent? You're guessing. Well, you're guessing. You're guessing. Oh, you made this a yeah, you can't. But I know this, right? I know there's 540 degrees in all of those angles, correct? So for this smaller one, I know I have 90 plus 150 plus 60, and that equals 390 degrees. 540 minus 390 gives me 150. So I know this angle C right here is 150 degrees, which means this one up, this angle D prime, that has to be 60 degrees. Yes, you were. You just couldn't prove it. Yes, you could not prove it. You were right, but you just didn't know how to prove it yet. So are these two similar? Yes, I know because all the measures of all the angles are congruent. They're similar. Okay, let's say I did not have that, though. Let's say I didn't have this angle measurement stuff. Could I do it another way? Yeah. I could. Yeah, let's check the corresponding sides. Very good. AB corresponds to A prime B prime. Well, AB is 4 centimeters, and A prime B prime is 6 centimeters, which reduces to what? 2/3 or what? 0.67, correct? Now, I'm going to stick with decimals on this one because look at this up here. That's a decimal there, which means I'm not going to be able to get a fraction out of it. It's going to end up being a decimal. All right, let's go up. Now look at ED and E prime D prime, and then DC and D prime C prime. They're what? Yeah, they're the same, right? I have 2.5 and 3.75 for both the ratios. So I only have to do one of them. So let's do ED corresponding to E prime D prime. And that gives me what? 2.5 over 3.75. And I divide that. 2.5 divided by 3.75. And that gives me, oh, look at that, 0.666 or 0.67. 0.67. Look at CB and CB and C prime B prime is what? And AE and A prime E prime, they're both what? Yeah, they're 2 over 3, right? The ratio of both of those is 2 over 3, which is 0.67. So we have proven both ways that these two are similar. So we could write that they are similar using either way. Tonight, you're going to have to do it both ways. Either they're going to give you the angle measures, and you have to figure it out, or they'll give you the lengths of the sides, and you have to figure it out by ratio. 476 and 477, 1 to 19 all.